Hi everyone, this is a video looking into prime numbers, what they are, and then going on to prime factors of a given number. We've got a starter here to complete first, do as much as you can of it, and then come on for the answers. Okay, so question 1, we are looking for the lowest common multiple of 3 and 4. So write out all your multiples of 3, write out all your multiples of 4. You've got 3, 6, 9, 12, 15. For 4, you've got 4, 8, 12, 16. You'll notice here that 12 is the lowest common one. When you do part B, you will find out that 30 is your lowest common multiple for those two. And part C, can't quite. 110 is your lowest common multiple between those two. Okay, that takes a lot of writing out the multiples to get to 110 for that one. Now, the highest common factor, so you're writing out all your factors of your two numbers and then finding the highest one. So for 12, you've got 1 and 12, 2 and 6, 3 and 4. For 15, you've got 1 and 15 and 3 and 5. So your common ones are 1 and 3, so the highest one between those two has to be 3. When we do 28 and 24, we get a highest common factor of 4, and 90 and 60, we get a highest common factor of 30 for those two. Okay. Now, you should have taken part in click the link and taken part in the sieve that I've asked you to do. So that's where you were to click number 1 and then click all of the numbers that were multiples of 2, then multiples of 3, 4, 5, 6, 7, 8, 9 and 10. I've done these in different colours here for the most part, but I've done everything that you would have done within that. So the list of numbers that are left are the numbers down the bottom there in blue. These are all known as prime numbers. They are the prime numbers between 1 and 100. There are more prime numbers than this, but we tend to only look at the ones under 100 just to keep things a bit more simpler. Okay. What each of these numbers have in common is that they only have 2 factors. So they have themselves and 1 as a factor. You cannot divide any of these numbers in this list by another number. 2, 5, 10, anything like that doesn't divide. Okay, only itself and 1. 1 is not a prime number because a prime number needs to have 2 factors. 1 can be divided by 1 and that is it. So 1 doesn't have 2 factors, it only has 1. Each of these numbers have 2 factors, themselves and 1. Therefore, they are prime numbers. So that's the definition of a prime number, and that activity was to lead you to these numbers down the bottom of the screen. Right, we have a bunch of different questions here, which I'm going to ask you to complete. So they're based on the questions that we did with multiples, factors, but also bringing in prime numbers as well. So, from the list of numbers up here, which numbers are multiples of 11? So that's numbers in the 11 times table. Pause this video and try and find them and then come back on for the answers. Multiples of 11, we have 55 and 121. I think that's them all. Which numbers are factors of 8? So numbers that we can divide 8 by. There's an 8, there's a 1, a 2, and there's also a 4 in this list as well. So that's all the factors of 8. Which are prime numbers. So we're looking at that list we just had in the previous slide. Numbers that can only be divided by themselves and 1. So that is 2, 3, 5. We've got 7 there as well. 13 and 23. Remember, not 1. and also not 121 might look like 1, but as you can see it can be divided by 11, so it can't be a prime number. Which 3 prime numbers add up to give you 20? So you're looking at the list here, finding 3 primes that add up to give you 20. Now for that one, I think there may only be one solution. 13, 2 and 5 would be your 3 numbers. 13 plus 2 plus 5 will give you 20. And lastly, which numbers are both a factor of 27 and 45? So you're looking for factors of 27, factors of 45, seeing which numbers fit the bill. So 9 is a factor of both, and 3 is a factor of both. 5 is a factor of 45 but not of 27, so that won't work. 27 is a factor of 27 but not of 45, so that won't work. And I think that's all we've got. Yep, the 9 and 3 are the only factors. Okay, so that was a look at our special numbers, kind of bringing them all together on that side. Now we're going to be moving on to look at prime factors, and more than that, we're going to be breaking a number up into its sole prime factors. Okay, so there's a wee analogy here that kind of introduces this to us. Primary colours of yellow, blue and red cannot be broken down into other colours. Okay, so we can't separate them out and get two other colours, but we can mix them together to make all other colours. That's the whole point of them being primary colours. Okay, prime numbers perform the same function in number form. We cannot break prime numbers down into smaller numbers, but we can multiply prime numbers together to make every other number. Okay, and we'll see that as we go through the rest of this lesson. So the way that we break down a number into its prime factors, we're going to use something called a factor tree. And I'm going to start with the number at the top, and I'm going to start with 2 branches. I need to find 2 numbers that multiply to give me 24. I've got 3 different options here, because there are 3 different ways to start this off. Now, we're not going to use the numbers 1 and 24, that's not going to break it up any. So we could use the numbers 2 and 12. Once we get to this stage, we decide, okay, can we break them up any further? The number 2 is a prime number, it can't be broken up. The number 12 can be broken into, say, 6 and 2. Yep, that would work. 2 is a prime number, we can't break that up, but the number 6 can be broken into 3 and 2. These numbers here are the prime factors of 24. So the prime factors of 24 are 2 and 3, and I could also say that 2 times 3 times 2 times 2 times all those together will make 24. Make sure that works in your head, just try it quickly and make sure it does actually work. Okay? So, what about the next one? We've got another factor of 24, right? So 2 numbers that multiply to give me 24. Let's try 3 and 8 this time. 3 is a prime number, so that can't go any further, but 8 can be split up into 4 and 2. 2 is a prime number, that can't go any further, but 4 can be split up into 2 and 2. Okay, so at each stage I'm looking for 2 numbers that multiply to give me the one above. That tells me that 3 times 2 times 2 times 2 will give me 24. And again, the prime factors of 24 are 2 and 3. Lastly, I could use 6 and 4 as my 2 factors of 24. So I'm looking for those 2 numbers that multiply to give me 24. 6 can be split up into 3 and 2, and 4 can be split up into 2 and 2. And after 2 lines, I have got, again, the same factors. 3 times 2 times 2 times 2. All those numbers will multiply to give me 24. So what is the same / different about these diagrams? They all end up with the same two prime factors of 3 and 2, but also they both end up with the same multiplications. Okay, multiplying all those factors at the bottom is going to always give me the 24. They are different because we started off with the first branch being different numbers, but that's okay because we've worked it right the way down to what's known as the prime decomposition. That's what that bottom section there is known as, prime decomposition. We've decomposed the number 24 into its prime numbers. Okay, that's what we've done for that process. Okay, so let's do the same for these numbers then. The number 12, first thing to do is take two numbers that multiply to give you 12. I'll go for 6 and 2. 2 is a prime number, so we don't take that any further, but 6 can keep going to 3 and 2. 3, 2 and 2 are my prime factors of 12. So I can say that 3 times 2 times 2 will give me 12. What about for 18? Let's use 9 and 2. Again, 2 is a prime number, so that can't go anywhere. And 9 can be split up into 3 and 3. 3 times 3 times 2 will give me the prime decomposition of 18. Lastly, 54. I'll go with 9 and 6 as my two numbers. So 9 can be split up into 3 and 3. 6 can be split up into 2 and 3. And I have 4 numbers here, which if I multiply them together, I get the number 54. Okay, so the prime factors of each of these numbers are just the numbers that are at the bottom. So 3 and 2 are the prime factors for 12, 3 and 2 are the prime factors for 18, and 3 and 2 are the prime factors for 54. It doesn't always have to be 3 and 2, it just so happens that these particular numbers have 3 and 2. Right, now these factor trees, as they're known, you've got 4 of them here. With this one, I would like you to try and fill in the blanks. And let's have a wee look. So, the first one, 5 times what will give us 30? That has to be 6. Therefore, 3 and 2 are our two bottom numbers. That tells me that 5 times 3 times 2. Notice there it doesn't have to just be 3 and 2 then. 5 is also a prime number. Right, we can take the right hand stem of 81 first of all, which is 9 here. And we got 3 and 3 inside those bubbles. 9 times 9 will give us 81. So again, we'll get 3 and 3 inside the bubbles. For 56, we are looking for prime factor. We're looking for a number that can be broken down multiple times. So you could try and do 7 and 6, but you realise that maybe wouldn't work to fill in all the boxes. So we'll need to do 2 and 18, and then 2 and 9, and then 3 and 3. That's quite a hard one to work out what it's actually wanting you to do. For 72, again, trial and error, different numbers inside those two first boxes, and then you'll work out it has to be 9 in this one to get 3 and 3, 8 in this one to get 2 and 4, and then 2 and then 2. Okay? So the idea today is that we're making these factor trees to try and find out the prime factors of certain numbers for one, but also the prime decomposition. So the prime factors are the numbers on their own. For 30 it is 5, 2 and 3. Those are the prime factors of 30. If I was to do 5 times 3 times 2, that's the decomposition. So for 81, 3 is the prime factor, and 3 times 3 times 3 times 3 is the prime decomposition. Okay, so the question might ask you specifically for one or the other of these, so just make sure that Do your factor trees first and then refer back to the video to decide which one you have to write down. Okay. You will have on the Teams page your worksheet, your questions to complete as well. Just work through them as best as you can and then make sure you ask me any questions if you're stuck on them. Okay, thank you for listening and